This short video talking about how to solve a quadratic, I guess in one of the simpler ways, or at least the simpler form of quadratic. What do we mean by this? Well, it's something that looks like this. 0 equals x squared plus, and we'll just work on any one of a pile of them we could have, 3x plus 2. We're going to try and solve this, which means we're searching for a value of x that makes this true. By true, I mean that this side of the expression will equal that side of the expression. So we're searching for a value of x that when you substitute it into there and there, you're going to calculate this side to be 0 equaling the other side. And the method is one of the more straightforward ones. We're actually going to be using x squared plus 3x plus 2 as our example. Okay, here's the quadratic that I mentioned just a moment ago. It's 0 equals x squared plus 3x plus 2. And the method we're working on, the method of decomposition, is to focus our efforts on this 3x in the middle there. And our aim, as written there, is to split it into 2. If we come right back down here, you'll see down the bottom that we've split it into 2. We've got an x and we've got a 2x. The purpose of the lines of working in between is to show you how we do that. In reality, when you're doing this in your books, you won't need to write as much as I've had. I'm just trying to give you a bit of an explanation. The critical thing we look for is we recognise that each of these three terms of the quadratic there, and there has a number involved. Okay, there's actually a 1 in front of the x squared, and then we've got a 3 there and a 2 there. So in this case, the 2 at the end is C, and the 3 there is B. Okay, just out of interest, that's going to be A. Now, the first thing we're going to do, excuse me, first thing we're doing is looking at C. C is 2. With practice, this will come fairly quickly to you, but there's two things to remember. The first thing is C, we find it by looking at its factors. So we're looking at the number 2 and we're asking ourselves, what are its factors? Well, here's a pair of factors. 1 and 2 give us 2. But there's another option as well. -1 and -2 also give us 2. But there are no other pair of numbers that can multiply together to give you 2. 3 and 1 is 3. Okay, so there's really no other pair of numbers. The only factors of 2 are 1 and 2. So, having written down the options, a list here of the 2 pairs of factors that could work, we now turn our attention to B. Okay, now B is 3. Now up here, C was 2, and we did factors. Well, down here, B is 3, and we're not doing factors at all. We're looking for numbers that add up to 3. But we don't need to start with an empty list, because the good news is we turn our attention to this group of pairs and look at the pair of them there and ask ourselves not what happens when we multiply them, but what happens when we add them. And you can see here for the first pair we get 3. Okay, now 3 is actually this middle term. If we do the -1 and the -2, you'll get -3, which is not the middle term. What it means is that this is our critical piece of information. It's telling us that 1 and 2 is 3. That's telling us that 1 times 2 is 2. Why does this matter? That's what we break it up into. We're going to break it up into 1 lot of x and 2 lots of x. So the whole point of this entire page here, all this working down there, is to split apart the middle term of the quadratic. On the next page I'll show you what to do about that. Okay, on the previous page we talked about how we got this line of working here, having split apart those pairs, or that split apart that middle term to give us a pair of terms. Having written it in this format here, okay, where the blue marks are, we are now going to focus on the first two terms, and you can see that there is a common factor, x. X is a common factor, and if we take x out of these two, you're left with x plus 1. So x times x plus 1 is the same as x squared plus x. We then do a similar thing for the second pair. I mentioned that the second pair. So that's the same as above, but now we're going to pull, in this case, a 2 out of each pair. You'll see it started with 2x plus 2. Well, if you pull a 2 out the front, you get x plus 1 as your bracket. Now what's very convenient and very useful, in fact it's necessary, is that this bracket and that bracket are the same. Because what it tells me is that I've got x lots of something plus 2 lots of something. X lots of something and 2 lots of something. So how many lots of something have I got? X plus 2. So I've got x plus 2 lots of something. Now if at this point in time you're scratching your head going, why bother, how did we get here? It's worthwhile potentially just looking at it and saying, what would happen if we expanded this all out? If we expanded it all out, you'd get 4 terms. And those 4 terms would look just like that. Okay? And if you wanted to, you could gather those 2 terms together and you'd get your 3x in the middle. So there's no denying the working here in the middle, where we've factorised our quadratic, is equal to the original quadratic. But what's good for us is that the solution is now in its factorised form. Okay? We talk about it being factorised because the solution is written as 2 quantities multiplied by each other. Now, I've talked previously about what the null factor law does, but the null factor law pretty much tells us that if at any point in time one of those brackets is 0, the answer must be 0. Why is this? Well, if the first bracket is 0, it doesn't matter what the second bracket's going to be, because 0 times anything is going to give you 0. And then we can flip it around and say, well, for the second consideration, if at any point in time you've made the second bracket 0, it doesn't matter what the first is, because you're still going to get 0 as your answer. So we talk here about the null factor law. And there's another video that details that. Having said the null factor law operates, the important thing to recognise is that the first of the factors is x plus 2. And we ask ourselves, what value does x have to make this thing equal 0? So over here in my working, I ask myself, we're looking for the solution to this. We're looking for the solution. We're asking ourselves, what number of x will make the bracket 0? And in this case, x is minus 2. Similarly, we're looking at the other bracket. So the x plus 2 bracket and the x plus 1 bracket are both being considered. If you're looking at the x plus 1 bracket, you'll find yourself thinking, what value of x is needed to make it equal to 0? What value of x? Well, it's got to be negative 1. And that's why we've got that negative 1 there. So we've got 2 answers. We've got x equals minus 2 and x equals minus 1. So there are 2 solutions, that one and that one.